Very important thing to understand is that the neurons in the areas of the cortex, your cortex and mine, that respond to particular tastes are providing an internal representation of an external sense. What do I mean by that? I don't want to be at all abstract. We take these foods, we break them down in our mouth by chewing them or sucking on them, whatever it is the food happens to be. Those chemicals bind to those receptors and electrical signals are sent into the brain. But they are just electrical signals, just like notes being played on the keys of a piano. There's no unique signature for salty or sweet. It is the relative activation of one set of neurons that was activated by sweet or another set of neurons that was activated by umami. It's that relative activation traveling into the brain in essentially the same form, the same electrical signals. This is really incredible, right? Electrical signals are sent into the brain and you say, aha, that's sweet and I want more of it, or that's bitter or I want less of it, or that's umami flavored and I really, really like that, really like savory foods. That should immediately strike you as incredible because it means that your representation of what you want more of or less of is electrical in nature. And to really tamp this issue down, studies that were done by Charles Zucker have shown that first of all, they could identify the neurons in the cortex, deep in the brain, that respond to a sweet taste or to a bitter taste. It turns out they are non-overlapping populations of neurons. And then, using some molecular tricks, they were able to either silence or activate the neurons that, for instance, respond to sweet. When they do this, they see incredible consequences on perception.